day everyone, my name is AUDREY. Today I am presenting a comprehensive case study on the Bakun Dam, which is located in Belaga, Sarawak. The Bakun Dam stands as a monumental infrastructure project on the Baloi River, a tributary of the Rajah River deep within Sarawak, Malaysia. As one of the Southeast Asia's largest hydroelectric dams, it plays a crucial role in Malaysia's energy landscape and symbolizes the nation's commitment to modern engineering and sustainable energy development. The dam was officially commissioned in August 2011 and has since become a landmark in the region. Belaga, the district where the dam is located, is known for its dense rainforests and indigenous communities. The strategic placement of the Bakun Dam allows it to harness the significant energy potential of the Baloi River, contributing electrification of vast areas. In terms of technical details, the Bakun Dam is a concrete-faced rock-filled dam, a design chosen for its stability and longevity. The dam rises to a height of 2,005 meters, making it one of the tallest in Southeast Asia, and its crest stretches 750 meters across the river. With an installed capacity of 2,400 megawatts, it is the largest hydroelectric dam in Malaysia and a major contributor to the national electricity grid. The reservoir created by the dam covers approximately 695 square kilometers, forming a vast water body that supports both energy generation and ecological functions. The purpose of Bakun Dam is to meet Malaysia's growing electricity demands through hydroelectric power. In terms of impacts, the construction of Bakun Dam has flooded large areas of rainforest and displaced thousands of indigenous residents who live in the area. Notable aspects of Bakun Dam include it has a complex history with multiple construction phases and financial challenges. It has significant environmental and social impacts that are still being discussed today. The project has also sparked debates on several issues, including sustainable development, indigenous rights, and how to balance economic growth with environmental preservation. Overall, the Bakun Dam project is not just a large-scale infrastructure, but it also highlights the challenges of development while protecting the environment and respecting local communities. That is all for the introduction of our presentation. We will continue with the next section. Thank you. So, the main objective of this study is to analyze the Bakun Dam's construction, engineering processes, operational performance, and the broader impacts it had on society and the environment. The study focuses on several key areas. First, it is to examine the construction methods and materials used, particularly the adoption of concrete-faced rock-filled dam construction techniques. Second, it analyzes the project management strategies, including the planning, execution, and management approaches that were critical to the dam's completion. Third, it assesses the environmental and social impacts, looking at how the dam has affected local ecosystems, wildlife, and indigenous communities. Fourth, it explores the technological advancements and sustainable practices implemented during the project. Finally, it compares the Bakun Dam with alternative dam building technologies and other major hydroelectric projects in the region, highlighting unique features and lessons learned. The study is limited to publicly available data, literature, and documented case studies on the Bakun Dam and similar projects. Some information may not be accessible due to confidentiality or lack of publication, which is a limitation to consider when interpreting the findings. So, let's move on to the research method of this case study. To ensure a thorough and credible analysis, the study employed a combination of research methods. The first method was observation, which involved a direct observation of the Bakun Dam's physical structure, the surrounding environment, and the operational facilities whenever possible. Photographic evidence was collected to document the dam's features and its environmental context, and data was gathered on dam's operation, maintenance activities, and interactions with local communities. The second method was document review. This included analyzing academic articles, engineering journals, and government reports related to the Bakun Dam. Technical documents such as blueprints, project reports, and technical specifications were examined to gain a deeper understanding of the engineering challenges and solutions involved in the project. Previous research on similar hydroelectric projects was also reviewed to draw relevant comparisons and insights. The third method was website research. Information was gathered from official government portals, energy agencies, and the dam's own website to obtain up-to-date statistics and announcements. Online articles, news reports, expert commentaries, and digital publications were reviewed to gain diverse perspectives on the project. Throughout this process, data reliability was ensured by cross-referencing multiple sources and verifying the information collected.
Hello everyone, my name is Wiwin Natasya binti Sutarno. Now, I will explain the construction method used for the cover dam in the Bakun Dam project. First, the process started with site preparation. The team cleared the river bank of vegetation and leveled the ground on both sides of Baloi River. Temporary access roads were constructed using compacted earth and gravel. This road allowed the smooth delivery of construction materials such as rock fill, steel sheet bars, and equipment like excavator and cranes. Next, a diversion tunnel was constructed to redirect the river flow. This tunnel was about 1.2 km long and was built by blasting and drilling through the adjacent hill. After excavation, the tunnel was lined with reinforced concrete to protect against erosion and to guide the river flow effectively. This tunnel played a critical role in diverting water away from the dam construction zone. Then, we move to the upstream cover dam. The upstream cover dam was installed before the main dam site. It was made using compacted soil and layer of large rock. The outer surface was reinforced with even large rock to prevent erosion from fast-moving river water. This structure successfully blocked the river, forcing the flow into the diversion tunnel and allowing the upstream side of the dam site to dry out. Fourth, the downstream cover dam. The downstream cover dam was constructed beyond the dam site. It was smaller than the upstream dam, but equally important. Its job was to prevent water from flowing backward into the construction area, especially during heavy rainfall or unexpected river surges. Like the upstream construction, it was built using rock fill and compacted earth. Next, to ensure safety, various monitoring instruments were installed. Piezometers were used to measure the pressure of groundwater behind the cover dam, while settlement markers track any ground movement or sinking. Regular visual inspection were also carried out to detect any sign of leaks, erosion, or cracks. Immediate repairs were made if problems were found to avoid failure or delay. And lastly, once the main dam structure was complete and strong enough to hold water, the cover dam was removed. The diversion tunnel was closed off, and water was allowed to flow naturally into the new dam reservoir. Some parts of the cover dam were dismantled, while others were left submerged underwater, become part of the reservoir base. Now, let's move on the advantage of using cover dam, especially in large-scale projects like the Bakun Dam. Firstly, cover dam create a safe and dry work area. By blocking and redirecting water flow, the construction team was able to perform foundation work like excavation, concreting, and reinforcement in a dry, stable environment. This greatly reduced the risk of accident and improved overall construction quality. Second, we have cover dam flexible and customized. They can be designed in various shapes, size, and configuration depending on the river flow rate, depth, and terrain. For example, the Bakun Dam project used two different cover dams. First, one upstream and downstream, each designed to fit specific site conditions. This flexibility made construction more efficient and safe. Third, cover dam offer usability and long-term cost saving. While the initial installation can be expensive, material like steel sheet parts and rock fill can often be reused in other phases of the project or in future work. This reduces the overall material cost over the life of the project, which is especially important for long-term infrastructure like hydroelectric dams. And lastly, cover dams help to minimize environmental impact. Because they enclose the work zone, they help to contain construction materials such as mud, cement slurry, and debris to preventing them from entering the river system. This reduces water pollution, sedimentation, and protection downstream aquatic habitat. At Bakun, careful environmental management during cover dam operation help reduce harm to the river ecosystem.
Problem determination and situation solved. Number 1. Water seepage and leakage. Water seepage and leakage are significant concerns in cover dam construction, as they can compromise the integrity of structure and pose a risk to workers. The common causes of water seepage and leakage include poor sheet piling, inadequate dewatering, and soil settlement or erosion. Water naturally follows the path of least resistance, and flow patterns change with geometry, especially in square or rectangular cover dams, which can be leading to underestimation of flow rates. The solution is to ensure proper sheet piling installation, implement effective dewatering system, monitor the cover dam for signs of leakage, add betonized slurry trench or plastic concrete cut-off walls outside the perimeter to reduce inflow. By using gloves, cotton to seal off high permeability zone or fractures in rocks, jet grouting under the slab can also create an impermeable barrier beneath the excavation base. Number 2. Structural integrity under load. The structural integrity of the cover dam is critical to ensuring the safety of workers and the success of the project. Factors that can affect the structural integrity of the cover dam include external loads, internal loads, and soil settlement or erosion. The scientists conduct throughout design analysis, implement robust construction technique, monitor the cover dam for signs of distress. Number 3. Environmental factors and mitigation. While cover dams are essential for providing dry work areas in water bodies, they can have significant environmental impact. Cover dam construction can have significant impact on the environment, particularly in sensitive ecosystems, which is water pollution, soil disturbance, and habitat disruption. Managing environmental impact while constructing a cover dam is crucial to protect the surrounding ecosystem, maintaining water quality, and complying with regulatory standards. To mitigate this impact, it is essential to conduct thorough environmental assessment, implement effective environmental mitigation measures, and monitor the cover dam for environmental impact. Articles of cover dams failure in the world. Here are the few articles about failed cover dams in the world. On the 9th of January 10, 2009, a portion of a cofferdam at Kusaha in Nepal, part of effort to close the massive Kosi River embankment bridge of August 2008, reportedly collapsed, causing widespread among the nearby residents. The Water Resource Department of Bihar immediately stepped in, assuring that the bridge closure works remain on track and that this kind of collapse was a routine, expected occurrence during construction. On January 2000,
is conclusion. In conclusion, cofferdam design and utilization are critical in achieving safe and effectiveness operation in waterlogged or submerged condition, particularly in bridge, dam, and foundation construction. From our case study, we have gained knowledge that meticulous planning, ground investigation, and selection of suitable types of cofferdam are necessary in order to ensure structural stability, worker safety, and project success. The study also highlighted challenges such as water seepage, unreliable ground, and weather conditions that require adaptive construction method and technical knowledge. Overall, the cofferdam topic informed our understanding on temporary work in building technology and underscored the importance of marine engineering solution and realistic site construction. That's all from me. Thank you.